All right, guys, here we go. So, we're going to talk about normal distributions, and those are a little different. I'm going to make this a little wider of a line. So, we're going to take the idea of the 12-year-old males from earlier, and we're going to say that our X bar or our mean is 149 centimeters, right? Okay, so really what we're doing when it comes to normal distributions is we're looking at this and going, okay, I got this number line here, right? And it's not very centered, but would you expect anything less from my beautiful writing here? And we put our X bar in the middle at 149. Now, our standard deviation is 9 centimeters. So really, if we were going to go 1, 2, and 3 standard deviations from the mean, we would go over here, and this one is 149 plus 8. And then this one here is 2 standard deviations, so it's 149 plus 16. And my final third one is 149, oh, not 16, it's not 8. You guys are probably going, Mr. Lasky, what are you doing? That's because I looked at the wrong, oh, that's ugly. All right, okay, this, what the heck? Come on, there we go. Okay, let's erase that. Some of you wrote in pen, and now you're irritated with me. Too bad. All right, so let's try this again. The standard deviation is 9. I should probably wear my glasses. Is 9. So the first one is 149, the X bar, plus 1 standard deviation. So this is X bar plus 1 standard deviation. This one is 149 plus 18, which is X bar plus 2 standard deviations. And then the final one is 149 plus 27, which is X bar plus 3 standard deviations. All right. So again, if I go to the other side here and I put 3 of them, my first point right here is going to be 100. It's going to be my X bar minus 1 standard deviation, which is going to be 149 minus 9. This side's going to be 149 minus 18. This is going to be 149 minus 27 because this one is X bar minus 3 standard deviations. Okay? So the idea is this. We just take our standard deviation, we add 3 of them to the right and 3 of them to the left. So it's like, okay, why 3? Well, let me tell you. So if we look at this here, we get some information, and I'm sure I'm going to read it wrong, so just hang in there. So if I go here and I find 26.8 of my standard deviation, sorry, 26 point, see, I told you, my mean is 26.8. So let's go 2, 4, 6. Let's call it right about here. We'll just estimate it. It's just an estimate. So it's right about there. That's my mean. So that's my X bar. And my standard deviation is 8.6, which is going to be 35.4. So I'm going to use a highlighter to show you this. So I'm going to go to 35.4, right? 28 and 8 is 34 plus 1.4. Yeah, 35.4. So I'm going to go from here. I'm going to go out 1 standard deviation, 32. Let's stop it right about there. That's 1 standard deviation away. And so if I go minus, if I subtract, that's 26 minus 8 is 18. So that's 18.8. So 18.2, right about there. Let's go 18.2, which is going to be right about here. Okay. So this line I created right there, guys, is 1, oh, it's plus or minus. All right. Plus or minus, that's a plus, 1 standard deviation. Okay, so I took the mean, I added one. Okay, now what I want you to do is, and it may be a little hard, but we're going to count. We're going to count dots that I highlighted. All right, we're going to count dots that I highlighted. So we're going to count. There's 2 here, 3. That's 6. That's a lot. I don't know. That's a lot. My head hurts already. So I'm going to count here. There's 3, 4, 3, 3, 5. I haven't counted these before, so then there's 4 more there, and then right in the middle there's 1, 2, 3. There's 5. Is that a 6? That was supposed to be a 6, and now I'm 6. Don't worry, don't write this stuff down, guys. I'm just counting here. 3. This one's got a lot of them. 1, 2, 3, 4. It looks like an 8. Doesn't have to be perfectly accurate. And there's 8 more there. Okay. And then there's 2, 4, 6, 8. There's 10 more there. All right. So there's 10 there. So let's add this up. 3 and 3 is 6. And there's 10 right there. There's 10 right there. There's 10 right there. And there is 8. 8 and 8 is 24. And there's 3. Sorry, I'm doing math in my head. So if you want to fast forward, go for it. So then I've got 10, 10, and 10. That's 30. 33. 33 plus 54 is 33 plus 24 is 57. So I got approximately 57 teams, or sorry, 57 games out of 82. So if we do that in our handy dandy calculator and get a proportion, here we got what I say, 57 divided by 82. 69.5%. Wrong writing pad there. 69.5%. And it's an estimate, okay, guys? So if I did the same thing here for strikeouts, and I did the same thing, and I went 1 standard deviation in between them and did the same thing, I would get approximately 68% of the data points. And if I kept doing it over and over, I would keep getting right around 68, 67 in there somewhere. Now, this is the cool part about statistics and probability. If I change this color and I decided to go out 8 more, so approximately 8 more, so go to about 10, and then 8 more from 35 is about 43, right? I would end up with 95% of them most of the time. To do the same thing here, if I went out 2 standard deviations, so if I find the X bar and 2 standard deviations, that's about 5. So we're going to go from 8 to right about here, and then from 8 to right about here. If I counted those up, that's 2 standard deviations here. Oops. That's 2 standard deviations, right? If I counted those up, I would get 95% of the data points, okay? So you could count those up, and what I would say is if you want to try it, it's just kind of an activity. You count dots within one plus or minus 1 standard deviation, and you divide it by the total dots. Okay? And if you divide it by the total dots, you're going to get approximately 68% every time. If you don't believe me, count them up. And then if you do 2 standard deviations, you're going to get approximately 95%. And if you repeat this over and over for all data sets, you come up with what is called the 68, 95, 99.7 rule. And when does it apply? It applies only to symmetrical or what we call normal. That's an N, sorry guys, normal distribution, okay? So this is what it looks like. So if we split it up even better, what we're going to say is look, if I add those 2 up, I get 68%. if I go to my highlighter, if I add these 4 data points up right here, so 13.5 plus 34 plus 34 plus 13.5, if I add those up, I get 95%. And then the last one, and this is true for all normal ones, the last one, green. And the last one, if I add up all three of them, okay? If I add up all 3 of them, I get 99.7%, okay? And then the last little bits are way out here, and we don't usually use those very much, so they're way out here like this. That was supposed to be red, guys. Sorry. Why is it being a punk? All right, here we go. No, that's the wrong color. I don't know, circle. Okay, so that's what the standard, the normal rule, or the 68, 95, 99.7 rule is. So when we look at this, so the idea is this, is that when I ask for probability, or when it asks for probability or proportion within a certain amount of standard deviations, you're going to say, what's the probability that a data point is within 1 standard deviation? Well, within 1 means I'm 1 to the left and 1 to the right. What is 34 plus 34? Well, that is 68. So what's the probability? The probability is equal to 68%. Okay? So that's the idea behind this thing. You can look at data and you can come up with the probability that something is going to happen. What about 2 standard deviations? Same thing. I'm going to add 2 standard deviations. I'm going to go from the -1 to the +1. And what do I get? I get the probability that 95% of the data is within two standard deviations. So we can write it this way. What is the probability of -2 is less than or equal to, let's call this standard deviations, which is less than or equal to 2. So when you see this, it's saying, what's the probability, P stands for probability, that the standard deviation is within what's the probability that's within 2 standard deviations? Well, the probability is, it is 95% probability. Okay, so we're just talking about probability, and there's all sorts of ways to write it, which is what we're going to get used to. So let's look at this. We're going to tie it into what we talked about earlier, our whole 9 centimeter standard deviation piece here, okay? So let's look at this. Now, number one thing I want you guys to understand is I put this data back in here. You don't have to do this. I already did this part. I'm just talking about, we're going to work on this piece right now. So let's read this here about what percentage of 12-year-old boys will be over 158 centimeters tall. All right, so let's write this first. So what this is really saying is, what's the probability that X is going to be greater than 158 centimeters? That's what it says, okay? All right. And so what we want to do, though, is we want to draw our normal curve. You don't have to draw it with all these little pieces. We want to draw our normal curve always. And then we're going to label it. So this is 149, right? And then this is 158 because I added 9 to it. And then this is 167 because I added 18, just like we talked about earlier. So my question is this. What is greater than 158? So if I go over here and I go to 158 and I shade this area over here, I want all these percentages over here. That's what I want for my probability. So my probability is equal to, I got to go back to drawing. My probability is equal to 13.5 plus 2.35 plus 0.15. That's these guys right here. Okay? That's those guys right there. So that is going to be This is 16%, I believe. So that's 2.52. Yep. So the probability is 16%. So the probability that a 12-year-old boy will be taller than 158 centimeters is 16%. 16% probability. Okay. So let's talk about the between items. So let's rewrite this. We got to have 149. You got to label these bad boys. And then we're going to subtract 9 this way, which is going to be 140. We're going to add 9, which is 158. We need 131, so let's go one more. So we're going to subtract 9 more, which gives us 131. So this is 131, and this one here is 158. So it says the word between. So what's the probability that X is between 131 and 140? Okay, you guys kind of see that? So we've set our boundaries. These are our boundaries, and now we got to shade wherever we're talking about. So I'm going to force this thing to do a different color. I'm going to fight it. Ready? You want to watch me fight it? Let's do this. Whoa, look at that. That's the one I wanted to originally. That one. Let's see what happens. Did it work? Yeah, buddy. All right, so we want all the percentages that are right here. Yeah, it was kind of dumb of me to do sky blue or whatever color you want to call that with light blue. Doesn't make any sense, but I was proving a point that I could do it. So if we look at this, what are the percentages that are right there? Well, those two make up 68%. And my other one that I have in between those 2 points is 13.5. Okay, so when I look at this, that's 80, that's 68, 81.5%. 81.5% of 12-year-old boys are between 131. Oh, I messed up. I didn't read the problem. It should be 140. So I hope you guys are sitting there screaming at me going, Mr. Lasky, you're totally doing that problem wrong. I know. So I wrote it right here, and then I didn't even catch it when I shaded this wrong. So let's erase that. Let's change colors. I apologize. And I really only want this one right here. I want in between those two because, like my problem says, is between 131 and 140, which is right here. I apologize. I didn't even want this stuff over here. I don't even know why I wrote that. What am I doing? So let's erase this. If you wrote in pen, you're probably mad at me again. Oh well, too bad. Mistakes happen. Okay, so let's tackle this bad boy here. This one's a little longer video. And so what do we got here? So we've got it is equal to 13.5%. All right, guys? All right, so now we've got all sorts of different pieces here that there's so many different ways they can ask this. So let's look at this here. They're asking us, suppose the distribution of test scores is approximately normal and the middle 95% of the scores are between 72 and 84. Let's see if I can not screw this one up. It's just my reading. Again, I should probably wear glasses. Sorry, guys. So if I look at this, I know middle 95. So if I go back all the way back to here, I'm going to slide back up. So if you look back a page or two standard deviations is 95%. So I got to go out 2 standard deviations here. So if I go out 2 standard deviations, let me go back to this one. I'm going to go out 2 standard deviations, and I'm going to do 72 and 84. That's what it's telling me, middle 95%. So I want the 95% is in between here. And it's asking me what the mean is. Well, what's right in the middle here? Well, the difference between here is 12. So halfway between that is 6. So this is going to be 78, right? because right in between 84 and 76 is 78. And then, so how did I get that? The distance here is 12. And so the middle has to be half of that, which is 6. And 72 plus 6 is 78. Now, there's so many different ways to look at this, guys. Now, I want to find the standard deviation. That's supposed to stay standard deviation, guys, of the distribution. Bunch of different ways to look at it. But since I know it's 12 apart, and I have 1, 2, 3, 4 standard deviations, so 12 divided by 4 standard deviations tells me that it's 3. So my standard deviation is 3. Okay? So that's kind of how you use this piece. Now here's the fun one. And this is where we're getting into what we're really going to dig into. So if I look at this, can you calculate the percent of scores that are above 80? Above 80. So we're talking about this thing that I was just working on. Uh-oh. What happened here? Oh no. Did it crash? That sucks. Nope. Hold on. Did you see that, guys? It's going crazy. Is it working? Oh, whew. I didn't get up. There's not going to be 40 seconds of me walking in the background anymore. So this goes back up to this one. It's asking, let me rewrite these for you guys. It's asking what percent of the test scores. Uh-oh. It's getting really wild. Do you guys see that? All right, let's try this again. It won't come off of that. I think I'm locking up. Uh-oh. Come on. Here we go. All right. Yeah, my mouse won't even move now, guys. All right. So if I look at 78 right here, I'm going to write 78 right here. And then I'm not going to change colors because I'm scared it's going to freak out, guys. And this is 84, right? They want to know the difference or the percentage at 80. Above 80. If you notice, 80 is in, we want above 80 over here, but 80 is in between 0 and 1. It's not a full standard deviation. So, can you figure it out? Yes, you can. But, so it's a yes, but you need to use z-scores. Okay? Yes, but you need to use z-scores. So that's kind of our idea today, guys. I'm going to go back and summarize. It's all based on this right here, the 68, 95, 99.7 rule. It's this graph. It's this percentage. If this is not on your formula sheet, you're going to have to get used to it and kind of almost memorize it. We use it a lot, so you'll memorize it by use only. But for today's information, and the reason I took a really long time on this one is it's very important. So you guys are working on this today, and then I will tackle this in class. Normal calculations we're going to do in class. It's very important we do them in class because I need to give you some things, and we need to talk about calculator and all this stuff at once. So I'm going to kind of do 2-in-1 on Tuesday. So be ready for a day of lecture on Tuesday, guys. A full day of lecture. I'll talk to you guys soon. Have a great 3-day weekend. And don't forget, I gave you the 3-day weekend off. Mr. Lindman did not.